3/60ths of a degree. That's how precisely the Great Pyramid aligns to true north, an accuracy we need satellites to match today. But the Egyptians had no satellites, no lasers, no modern surveying equipment, just copper chisels and starlight. What they accomplished shouldn't be possible, yet the evidence is carved in stone. We're about to crack the lost science behind this impossible feat. And real quick, before we continue, if you're enjoying this, please subscribe. It helps us keep making videos like this, and honestly, the next mystery we're covering is even crazier. The Great Pyramid of Giza stands as a testament to an ambition that transcends the boundaries of time, a colossal structure of limestone and granite rising from the desert plateau. For 4.5 millennia, it has dominated the horizon, casting a long shadow over the history of human engineering. While the sheer scale of the monument, comprising some 2.3 million stone blocks, often captures the imagination, the true marvel lies not in its size, but in its exactitude. This is a structure built with a degree of accuracy that rivals modern optical equipment, a feat accomplished in an age before the wheel was widely utilized for transportation and when tools were crafted from copper and stone. The base covers more than 13 acres, a massive footprint that remains level to within a fraction of an inch, creating a platform of near-perfect horizontality upon which the mountain of stone rests. The orientation of the Great Pyramid presents a statistical impossibility that has baffled surveyors and archaeologists for centuries. The four sides of the pyramid are aligned to the four cardinal points of the compass, true north, south, east, and west, with an accuracy that is chilling in its precision. Modern measurements, utilizing laser theodolites and satellite positioning systems, have revealed that the structure deviates from true north by only 3/60ths of a degree. This equates to an error of roughly 3 arc minutes. To put this into perspective, most modern buildings are not constructed with such rigorous adherence to cardinal alignment, and the deviation is so slight that the human eye cannot perceive it. This alignment is not magnetic north, which shifts with the molten currents of the Earth's core, but true north, the celestial pole around which the heavens appear to rotate. Achieving this level of orientation required a mastery of engineering and surveying that seems incongruous with the technological landscape of the Old Kingdom. The builders of the Fourth Dynasty did not possess the telescope, the compass, or the sextant. They worked without the complex trigonometry that would define later architectural eras. Yet they managed to lay out a square base with sides measuring over 750 feet, where the difference between the longest and shortest side is less than 8 inches. This creates a squareness that is almost perfect. The questions arising from this data are immediate and demanding. How did a civilization relying on simple sighting tools and manual labor achieve a degree of precision that modern engineers would find challenging to replicate without digital assistance? Leading Egyptologists and archaeoastronomers have spent decades attempting to reverse engineer the methods of the royal architects. Figures such as Sir Flinders Petrie, who conducted the first highly accurate triangulation survey of the Giza Plateau in the late 19th century, laid the groundwork for understanding this precision. Contemporary researchers like Kate Spence and Glenn Dash have furthered this inquiry, proposing theories that link this architectural exactitude to the celestial mechanics of the night sky. The investigation into the Great Pyramid is not merely a study of stones and ramps, but a forensic examination of the ancient mind. It suggests a methodical, scientific approach to construction where observation, hypothesis, and execution were tightly controlled. The mystery is not just how they moved the stones, but how they knew exactly where to place the first one. The sky above the Egyptian desert is a vast, unobstructed canvas, and for the ancients it was a realm of gods and a clockwork mechanism of eternity. The Egyptians were keen observers of the celestial sphere, driven by a religious imperative that linked the pharaoh's destiny with the stars. They identified a specific group of stars in the northern sky, known as the imperishable ones, or the circumpolar stars. These are the stars that never set below the horizon, rotating endlessly around the celestial pole. For a culture obsessed with the concept of the afterlife and eternal existence, these stars became the perfect metaphor for immortality. The alignment of the pyramid to true north was not a purely aesthetic choice, but a theological necessity, ensuring the king's soul could ascend to the northern sky and join the retinue of the sun god Re and the star god. Surviving texts and artifacts provide a window into this sophisticated astronomical worldview. The pyramid texts, carved into the walls of later pyramids, are replete with stellar references, describing the king's journey to the sky to become a star. The ceiling of the tomb of Senenmut, dating to a later period but reflecting older traditions, features a detailed star map, separating the northern and southern skies and identifying specific constellations like Orion, known to them as Sa, and Sirius, known as Subdet. These were not abstract dots of light, but deities whose movements dictated the flow of time and the flooding of the Nile. The heliacal rising of Sirius, the moment the star first appeared on the horizon at dawn after a period of invisibility, marked the Egyptian New Year and heralded the life-giving inundation. This precise calibration of the calendar demonstrates a culture deeply attuned to the cyclical nature of the cosmos. The integration of astronomy into architecture required a deep understanding of stellar mechanics. The Egyptians recognized that while the sun traveled a path across the southern sky, the north was the anchor of the heavens. However, there was no North Star as we know it today. Due to the precession of the equinoxes, a slow wobble in the Earth's axis over a 26,000-year cycle, the star Polaris was nowhere near the celestial pole in 2500 BCE. Instead, the pole was a dark point in the sky, surrounded by the faint stars of the constellation Draco and the brighter stars of the Big Dipper and Little Dipper. The ancient astronomers had to locate an invisible point in the void, a challenge that required rigorous observation over years or even decades. Experts in archaeoastronomy argue that the alignment of the pyramids reflects this changing sky. By analyzing the slight shifts in alignment of pyramids built over successive generations, researchers have been able to correlate the orientation errors with the precessional drift of specific stars. This suggests that the Egyptians were not using a static method, but were constantly adapting their techniques to the slow rotation of the heavens. The alignment of the Great Pyramid represents the apex of this effort, a moment in time when their observational techniques aligned perfectly with the stellar configurations, allowing them to lock the massive stone structure into the grid of the cosmos. The instruments used to achieve this monumental alignment were deceptively simple, relying on human acuity and patience rather than mechanical complexity. The primary tool in the ancient surveyor's kit was the merket, resembling the rib of a palm leaf. The merket was a sighting tool, a narrow bar with a vertical slit. It was often used in conjunction with a bay, a sighting rod with a V-shaped notch cut into the top. By looking through the slit of the merket and aligning it with the bay held by an assistant at a distance, an astronomer could establish a precise meridian line. These tools, made of wood and bone, have been found in excavations, confirming their use in ritual and construction contexts. They allowed the observer to track the movement of stars across the night sky and mark their positions on the horizon. One of the most enduring theories regarding the method of alignment involves the use of shadows. The Indian circle method is a technique that requires nothing more than a vertical stick, known as a gnomon, and a piece of string. As the sun rises and climbs the sky, the shadow of the stick shrinks. As the sun descends in the afternoon, the shadow lengthens again. By marking the tip of the shadow at regular intervals throughout the day, a curve is created on the ground. The surveyor then draws a perfect circle around the gnomon. The points where the shadow curve intersects the circle represent moments when the sun is at equal altitude in the morning and afternoon. A line connecting these 2 points runs perfectly east-west. Bisecting this line creates a perfect north-south meridian. This method is elegant, requiring no view of the night sky, and yields high accuracy if the measurements are taken near the summer solstice. Another potential technique involved observing the transit of stars. The simultaneous transit theory suggests that the Egyptians watched 2 specific stars in the northern sky, such as Mizar in the Big Dipper and Kochab in the Little Dipper. As the Earth rotates, these stars appear to circle the pole. When the 2 stars are vertically aligned, one directly above the other, an imaginary line drawn through them passes very close to true north. An observer using a plumb line, a simple weight on a string, could wait for this moment of vertical alignment and mark the direction. This method explains the slight variations in pyramid alignment over the centuries, as the positions of these stars shifted relative to the pole due to precession. Mathematics played a crucial role in translating these observations into stone. The Egyptians used a system of geometry based on the sect, which measured the slope of a surface. While they did not use degrees or angles in the modern sense, their understanding of ratios allowed them to maintain consistent slopes and right angles across vast distances. The Rhind mathematical papyrus contains problems explicitly dealing with the calculation of pyramid slopes, proving that the architects possessed the theoretical framework necessary for such precision. The stretching of the cord ceremony, depicted in temple reliefs, shows the pharaoh and the goddess Seshet driving stakes into the ground and stretching a measuring cord between them, guided by the stars. This ritual enactment of the foundation layout underscores the blend of sacred duty and practical surveying that defined the construction process. In the quest to solve the riddle of the pyramid's orientation, modern researchers have moved beyond theoretical papers and into the field of experimental archaeology. Archaeologist and engineer Glenn Dash conducted a series of experiments in Pomfret, Connecticut, to test the feasibility of the Indian circle method. Using a simple wooden gnomon and a level platform, Dash tracked the shadow of the sun on the autumnal equinox. His experiments demonstrated that the method could consistently produce a line running east-west with a high degree of accuracy, matching the error range found in the Great Pyramid. Dash's work suggests that the builders could have achieved their results using the sun rather than the stars, specifically by utilizing the equinox when the shadow travels in a nearly straight line. Comparison of these experimental results with the actual data from the Giza Plateau reveals striking correlations. The Great Pyramid, the Pyramid of Khafra, and the Pyramid of Menkaure all exhibit slight deviations from true north, but the direction of the error changes slightly over time. This pattern corresponds with the simultaneous transit theory involving the stars Mizar and Kochab. In 2467 BCE, the vertical alignment of these stars would have pointed exactly to true north. Before and after this date, the alignment would drift. The Great Pyramid, built closest to this optimal date, is the most accurate. The subsequent pyramids show increased deviation consistent with the stellar drift. This comparative analysis strongly supports the stellar method over the solar method for the initial orientation, although solar methods may have been used for cross-checking. Modern surveying equipment has clarified the extent of the ancient achievement. Using total stations and GPS, surveyors have mapped the base of the Great Pyramid to within millimeters. These studies confirm that the builders maintained the orientation not just at the corners, but along the entire length of the sides. This implies that they had a method for extending a straight line over uneven terrain without losing accuracy. It is likely they used a system of sighting posts, correcting for parallax errors as they went. The experiments show that while the tools were primitive, the methodology was rigorous. A team of surveyors, likely priests trained in astronomy, would have spent weeks or months verifying the lines before the first stone was laid. Expert commentary on these experiments highlights the ingenuity of the simple solution. Complex problems do not always require complex tools. They often yield to consistent application of basic principles. The feasibility of the circle method or the stellar transit proves that the ancient Egyptians were not possessors of lost alien technology, but were masters of their environment. They understood the geometry of light and shadow and the regularity of the celestial motions. The modern verification of these techniques bridges the gap between the copper chisel and the laser, showing that the intellectual capacity of the Old Kingdom architects was fully equal to the challenges they set for themselves. The obsession with precision at Giza extends far beyond the cardinal alignment of the base. The engineering tolerances found within the structure and in the casing stones reveal a dedication to perfection that borders on the obsessive. The Great Pyramid was originally covered in highly polished white Tura limestone. Only a few of these casing stones remain at the base today, but their joinery is legendary. The stones were cut with such exactitude that the joints are often less than 1/50th of an inch wide. A knife blade cannot be inserted between them. Often, the joints were filled with a thin layer of gypsum mortar, not to bond the stones, but to act as a lubricant to slide the massive blocks into place with airtight precision. This level of masonry work creates a seamless surface that would have made the pyramid shine like a singular crystal under the Egyptian sun. The internal architecture mirrors the external precision. The descending passage, which leads from the entrance down into the bedrock beneath the pyramid, is a marvel of tunneling. It maintains a constant angle of 26 degrees for over 300 feet. This bore is so straight that it deviates by only a fraction of an inch over its entire length. Archaeoastronomers have noted that at the time of construction, this passage pointed directly at Thuban, the star in the constellation Draco that served as the pole star of that era. This alignment suggests that the passage was designed as a telescope of sorts, permanently fixing the gaze of the pyramid on the imperishable center of the sky. Deep within the pyramid, the so-called air shafts, extending from the king's and queen's chambers, offer further evidence of celestial intent. These narrow shafts, only inches wide, cut through the solid masonry at steep angles to reach the exterior. They are not merely ventilation ducts. Their angles correspond to the culmination of specific stars. The southern shaft of the king's chamber pointed to El Nitak in the belt of Orion, the symbol of Osiris, the god of resurrection. The northern shaft pointed to Thuban. The southern shaft of the queen's chamber targeted Sirius, the star of the goddess Isis. These shafts connect the internal burial chambers directly to the stellar deities, creating a magical conduit for the soul of the pharaoh to ascend. The engineering required to maintain these angles while stacking millions of stone blocks is a feat of three-dimensional planning that rivals any modern construction project. The leveling of the plateau itself was a prerequisite for this geometric perfection. Before construction began, the builders removed a massive hill of sand and rock and leveled the limestone bedrock. They likely used a network of water-filled trenches to establish a horizontal plane. By cutting a grid of trenches and filling them with water, the water level would provide a perfect reference. Measuring down from the water surface allowed them to level the rock islands between the trenches. The resulting base for the Great Pyramid is level to within barely an inch across its entire 13-acre area. This foundational precision ensured that the errors did not compound as the structure rose, allowing the apex to meet directly over the center of the square base, 481 feet in the air. The precision alignment of the Great Pyramid reveals a civilization operating at the peak of its cognitive and organizational capabilities. It challenges the linear view of history that suggests technological progress is a steady upward slope. Instead, the evidence at Giza points to a spike in capability, a moment where cultural will, religious fervor, and observational science coalesced to produce a masterpiece. The knowledge required to execute this project was not written in textbooks, but was passed down through guilds of scribes, priests, and master masons. It was a knowledge born of deep time, generations of watching the stars, recording the floods, and working the stone. This investigation forces a reconsideration of what constitutes technology. We often equate technology with machinery and electronics, but the Egyptians possessed a social technology of immense power. They could mobilize, feed, and direct a workforce of thousands with the efficiency of a machine. They possessed a cognitive technology that allowed them to visualize complex three-dimensional geometries and execute them with simple tools. The loss of this specific knowledge, the exact method of the survey, the specific rituals of the foundation does not diminish the achievement, rather it highlights the fragility of human know-how. When the cultural imperative to build pyramids faded, the specific techniques for aligning millions of tons of stone to the stars faded with it, eventually becoming the stuff of legend and mystery. Modern engineers and architects look to the Great Pyramid not just as a historical curiosity, but as a benchmark of durability and design. The structure has survived earthquakes, erosion, and vandalism for thousands of years, largely due to its precise construction. The interlocking stones, the leveled base, and the careful distribution of weight are lessons in structural integrity. Contemporary projects often sacrifice longevity for speed or cost, but the pyramid builders prioritized eternity. Their work reminds us that true sustainability in architecture requires a deep understanding of materials and the environment. The significance of the Great Pyramid's alignment lies ultimately in what it tells us about the human spirit. It is a physical manifestation of the desire to connect the earth with the sky, the mortal with the immortal. The deviation of 0.15 degrees is not an error in the modern sense. It is a signature of humanity reaching for perfection. The research into these ancient methods continues, with new technologies like muon scanning and digital modeling revealing more secrets every year. Yet the core truth remains: 4,500 years ago, people stood on a windswept plateau, looked up at the silent stars, and built a mountain that mirrored the order of the cosmos. To truly grasp the magnitude of this achievement, we must strip away the modern light pollution that bleaches our night sky and imagine the Giza Plateau as it was in the 3rd millennium BC. The atmosphere was pristine, the air dry and stable, turning the celestial dome into a high-definition map of glittering diamond points. In this era, the concept of north was not merely a cardinal direction on a map, but a sacred destination, the realm of the indestructibles. These were the circumpolar stars, the ones that never dipped below the horizon to die in the west, but circled eternally around a fixed point in the heavens. For a pharaoh obsessed with the afterlife, aligning his tomb with these undying stars was not an architectural choice, but a theological necessity. It was a mechanism for the soul's survival, ensuring that the king could ascend to the northern sky and join the cosmic dance of the immortals. This religious imperative drove the engineering precision, demanding that the pyramid be oriented with an accuracy that rivals the best optical equipment available to surveyors today. The star we know as Polaris, the current North Star, was nowhere near the celestial pole during the construction of the Great Pyramid. Due to the slow wobble of the Earth on its axis, a phenomenon known as the precession of the equinoxes, the celestial pole shifts over a cycle of 26,000 years. In the age of Khufu, the pole was an empty point in the sky, a dark void around which the heavens turned. The closest bright star was Thuban, located in the constellation of Draco the Dragon. Thuban served as a faint but reliable marker, yet it was not precisely at the pole. This presented a complex geometric problem for the Egyptian astronomers. They could not simply sight a single stationary star and drop a plumb line. They had to observe the rotation of the night sky and calculate the invisible center of that rotation. This required patience and a methodology that relied on the movements of star pairs, waiting for the precise moment when specific stars stacked vertically above one another to indicate true north. One of the most compelling theories regarding this alignment method involves the stars Kochab in the Little Dipper and Mizar in the Big Dipper. In the year 2467 BC, a date that aligns neatly with the historical timeline of the Great Pyramid's construction, these two stars circled the celestial pole in such a way that a vertical line drawn between them would pass directly through the true North Pole. This is known as the simultaneous transit theory. An observer standing on the plateau could have held up a plumb line and waited for the moment when Kochab was directly above Mizar. At that exact instant, the string would mark perfect, true north. What makes this theory so seductive to historians and astronomers is that it explains the slight error in the pyramid's alignment. Over the century that the Giza pyramids were built, the precession of the equinoxes would have slowly shifted the alignment of these two stars relative to the pole. If the builders continued to use this method without correcting for the shift, the resulting structures would show a predictable drift in their orientation. When we measure the alignments of the pyramids of Khufu, Khafre, and Menkaure, we see exactly this pattern of drift, matching the stellar movements of that specific epoch. The execution of this stellar observation required tools that were deceptively simple, yet capable of extreme precision in the hands of a master. We know from reliefs and hieroglyphic texts that the Egyptians used an instrument called the merkit, which was essentially a notched palm rib, and a bay, which was a sighting tool made from a distinctively shaped piece of wood. Two observers would stand a specific distance apart. The first observer would look through the slit in the bay, aligning their sight with the merkit held by the second observer against the backdrop of the night sky. By utilizing a plumb bob to ensure verticality, they could track the transit of stars across the meridian. This was not a quick glance at the sky, but a ritualized scientific observation that likely took place over many nights to average out any potential errors caused by atmospheric refraction or human unsteadiness. The ceremony associated with this foundation ritual was known as the stretching of the cord, a scene often depicted on temple walls where the pharaoh and the goddess Seshet are shown driving stakes into the ground and pulling a measuring rope taut. While the stellar methods offer a compelling explanation for the primary orientation, we must also consider the role of the sun. The solar gnomon method is another technique that requires no advanced technology, only time and geometry. By placing a vertical stick or gnomon in the ground and marking the shadow it casts throughout the day, an observer can determine true north. As the sun rises and sets, the shadow shrinks and then lengthens. By marking the tip of the shadow at regular intervals, a curve is created on the ground. If one draws a perfect circle around the gnomon and marks the 2 points where the shadow tip touches the circle, once in the morning and once in the afternoon, bisecting the angle between these 2 points yields a line running perfectly north-south. This is known as the Indian Circle method. However, for a structure as massive as the Great Pyramid, a simple stick would not suffice. The penumbra, the fuzzy edge of the shadow cast by the sun, makes pinpointing the exact tip difficult, introducing a margin of error that exceeds the precision found in the Great Pyramid. To achieve the accuracy of 3 arc minutes, the gnomon would have needed to be monumental in size, perhaps a needle-like obelisk, or the observations would have required a pinhole device to sharpen the shadow, a technology that leaves no archaeological trace but remains a theoretical possibility. The challenge of alignment did not end with establishing a north-south line. That was merely the first step. The builders then had to transfer this celestial line onto the physical, undulating bedrock of the plateau. The Giza Plateau is not a flat table. It is a natural limestone formation with hills, dips, and imperfections. Before a single block could be laid, the site had to be leveled. The degree of flatness achieved is startling. The base of the Great Pyramid varies in level by less than an inch over an area of 13 acres. This creates a perfect artificial horizon, a necessity for accurate astronomical observation. If the foundation were tilted even slightly, any vertical measurements taken from it would be skewed, throwing off the geometry of the entire structure. To achieve this, it is believed they cut a grid of trenches into the bedrock, filled them with water, and used the water surface as a self-leveling reference. By measuring down from the water level, they could carve the rock island between the trenches to a uniform height, eventually creating a platform as flat as a modern optical table. Once the cardinal directions were established and the base leveled, the architects faced the logistical nightmare of maintaining that orientation as the pyramid rose. It is one thing to draw a perfect square on the ground. It is entirely another to maintain that square as you stack 2 million blocks of stone to a height of 481 feet. A deviation of a fraction of a degree at the base would spiral into a massive twist by the time the structure reached the summit. This implies that the surveyors were constantly rechecking their alignment at every course of masonry. They likely utilized the internal shafts of the pyramid not just for ventilation or religious symbolism, but as sighting tubes. The so-called air shafts in the king's and queen's chambers point to specific stars: Orion's belt, Sirius, and the circumpolar stars of the north. During construction, before the roof of the chamber was sealed, these shafts could have provided a direct line of sight to the heavens, allowing the builders to verify their orientation from deep within the growing mountain of stone. The precision of the Great Pyramid is often cited as proof of lost technology, but it is perhaps more accurately described as proof of lost methodology. We live in an age of digital immediacy, where we expect tools to do the work for us. The Egyptians lived in an age of analog patience. They compensated for the lack of lasers and satellites with an abundance of time and manpower. If a measurement needed to be checked 1,000 times to ensure accuracy, they had the labor force to check it 1,000 times. The cultural concept of meta, roughly translating to truth, balance, and cosmic order, meant that creating a perfect structure was an act of maintaining the stability of the universe. A crooked pyramid was not just an eyesore, it was an affront to the gods, a chaotic element that could destabilize the journey of the pharaoh, and by extension, the prosperity of the land. This theological pressure ensured that quality control was arguably more rigorous than on any modern construction site. The internal geometry of the pyramid reveals that this obsession with alignment permeated every aspect of the design. The descending passage, which cuts into the bedrock beneath the pyramid, is straight to within a fraction of an inch over a length of 350 feet. It points directly at the position where the pole star would have been at its lowest culmination. This passage acts as a fixed telescope, permanently frozen in stone. To carve a tunnel at a steep 26-degree angle through solid limestone, with such unwavering straightness, requires a mastery of subterranean surveying that is difficult to comprehend. The workers would have needed to carry the line of sight down into the darkness, using oil lamps that generate smoke and heat, likely relying on a system of offset markers on the ceiling or floor to keep the tunnel from drifting. The fact that they achieved this without modern theodolites suggests a reliance on simple, robust geometric principles applied with fanatical care. We must also consider the sheer scale of the materials being manipulated to adhere to these alignments. The casing stones, the smooth outer shell of the pyramid, were cut with such precision that the joints between them are thinner than a credit card. These blocks weighed tons, yet they were positioned with the delicacy of a jeweler setting a gemstone. The mortar used was not merely a bonding agent, but a lubricant, allowing the massive stones to be slid into place and adjusted minutely until the alignment was perfect. Once the mortar set, the stones were locked in an embrace so tight that they effectively became a single monolith. This structural integrity was essential for maintaining the alignment over millennia. If the pyramid had settled unevenly, or if the stones had shifted significantly due to thermal expansion and contraction, the precise orientation to true north would have been lost. The builders anticipated the forces of nature, earthquakes, wind, and gravity, and designed a structure capable of absorbing them without losing its geometric purity. The relationship between the Great Pyramid and the dimensions of the Earth itself adds another layer of complexity to the alignment discussion. Some researchers argue that the pyramid is a scale model of the Northern Hemisphere. If you take the height of the pyramid and multiply it by 43,200, you get a figure remarkably close to the polar radius of the Earth. If you take the perimeter of the base and multiply it by the same number, you get the equatorial circumference. The number 43,200 is not arbitrary. It is derived from the precession of the equinoxes, representing 20 times the number of years it takes for the equinox to shift 1 degree. While orthodox Egyptologists often dismiss these correlations as coincidental, the mathematical precision is difficult to ignore. It suggests that the builders possessed a knowledge of the Earth's dimensions that was not rediscovered until the modern era. Whether this knowledge was empirical or derived from an esoteric tradition remains a subject of fierce debate, but the physical evidence of the alignment suggests a worldview that integrated astronomy, geodesy, and architecture into a unified science. This integration of disciplines is foreign to our modern compartmentalized academic structure. We separate the astronomer from the architect, the theologian from the engineer. In ancient Egypt, these roles were often held by the same class of high priests. The overseer of works was not just a logistics manager, he was a master of the sacred mysteries. The alignment of the pyramid was a liturgy performed in stone. The layout of the Giza plateau itself appears to be a terrestrial reflection of the sky, with the 3 main pyramids mirroring the belt stars of Orion and the Nile River serving as the earthly counterpart to the Milky Way. This as above, so below philosophy meant that the alignment had to be perfect because the pyramid was intended to function as a machine of resurrection. If the gears of this machine, the shafts, the passages, the orientation, were not aligned with the celestial mechanism, the soul of the king would be lost in the void. Analyzing the casing stones gives us further insight into the practical application of this alignment. The few remaining casing stones at the base of the Great Pyramid display a level of workmanship that surpasses the internal masonry. These stones were the interface between the structure and the world. Their faces were angled to produce the perfect 51-degree slope, a ratio known as the sect. The surveyors had to ensure that each side of the square base was perfectly straight, and that the corners were perfect 90-degree angles. A slight error in the corner angle would result in the faces of the pyramid twisting as they rose. The fact that the pyramid meets at a perfect point at the summit, with the apex directly over the center of the base, proves that the square was maintained with absolute rigor from the bottom to the top. This required a system of constant verification, likely involving sighting lines running up the center of each face and diagonal checks across the corners. The durability of this alignment is evidenced by the fact that we can still measure it today. Despite thousands of years of erosion, earthquakes that shattered the casing, and the quarrying of the outer stones for the building of Cairo, the core masonry retains its orientation. This resilience speaks to the depth of the foundation work. The builders did not just place stones on the sand, they anchored the pyramid into the living rock. They understood the geology of the plateau, identifying the most stable strata to bear the 6 million tons of weight. This geological awareness was a prerequisite for the astronomical alignment. You cannot build a precision instrument on a shaky table. The stability of the Giza Plateau was the silent partner in the alignment process, providing the unmoving stage for the builder's celestial performance. Furthermore, the alignment of the Great Pyramid serves as a chronological marker. Because the orientation is linked to the position of the stars, and because the stars move due to precession, the alignment freezes a specific moment in time. It allows archaeoastronomers to date the construction with a method independent of carbon dating or king lists. The slight deviation from true north corresponds to the position of the pole stars in the mid-3rd millennium BC. If the pyramid had been built 500 years earlier or later, the alignment method used would have produced a different error, or a different pair of stars would have been chosen. This stellar fingerprint connects the stone monument to the clockwork of the galaxy, providing a temporal anchor that validates the historical timeline while simultaneously showcasing the sophistication of Old Kingdom science. We must also reflect on the transmission of this knowledge. How was such a complex set of astronomical and engineering data passed down? There were no textbooks in the modern sense, no CAD files. The knowledge was likely oral and experiential, transmitted from master to apprentice within the closed circles of the temple guilds. The House of Life, the institution attached to temples where scribes and priests were trained, would have been the repository for this wisdom. The alignment of the pyramid was the culmination of centuries of experimentation, from the step pyramids of Saqqara to the failed attempts at Meidum and Dashur. The bent pyramid, with its sudden change in angle, and the red pyramid, the first true smooth-sided pyramid, were the proving grounds where the Egyptians learned the hard lessons of structural stability and orientation. The Great Pyramid was the masterpiece born from these generations of trial and error. The tools found in the archaeological record, while simple, show a deep understanding of physics. The plumb bob, for instance, relies on gravity to provide a perfect vertical line. By combining the vertical plumb line with the horizontal water level, the Egyptians created a coordinate system defined by the natural forces of the Earth. They didn't need to invent complex theories of vector calculus. They simply harnessed the immutable laws of nature. Gravity does not lie. Water does not tilt. By surrendering to these natural constants, they achieved a perfection that eludes those who try to force materials against their will. The alignment of the pyramid is, in essence, a harmony between human ambition and natural law. Comparison with other ancient cultures highlights the uniqueness of the Egyptian achievement. The Maya, for example, also aligned their structures with celestial bodies, particularly Venus and the Sun. Stonehenge is oriented to the solstices, but none of these structures combine the colossal scale of the Great Pyramid with such exacting cardinal precision. The intent at Giza was different. It was not just about marking a season or tracking a planet. It was about creating a static, eternal link to the unmoving center of the sky. The pole represents stillness in a moving universe, a fitting target for a tomb designed to last forever. This specific goal necessitated the unique engineering solutions we observe, pushing the builders to the limits of what was physically possible with copper chisels and stone hammers. The mystery of the circle of the horizon also plays into the alignment. The Egyptian term ****, often translated as horizon, refers to the place where the sun rises and sets, but also to the concept of the mountain of light. The pyramid was an artificial mountain, an ****, constructed to facilitate the king's rebirth. The precision of the alignment ensured that the sun would rise and set in the correct relationship to the pyramid during critical times of the year, such as the equinoxes. On the equinox, the sun rises due east and sets due west. Because the faces of the pyramid are aligned so perfectly to the cardinal points, the play of light and shadow on the equinox creates a spectacular visual effect. For a brief moment, the concave centers of the pyramid's faces, a subtle feature not always visible, split the face into two distinct triangles of light and shadow. This flash effect confirms the extraordinary accuracy of the orientation and suggests that the alignment was intended to produce visual phenomena that reinforced the solar theology of the state. The sheer stubbornness required to maintain this alignment suggests a centralized authority with absolute control over resources. This was not a project that could tolerate dissent or deviation. Every quarrymaster, every scribe, every stone hauler had to be subjugated to the single purpose of the alignment. The logistical network extended hundreds of miles, from the granite quarries of Aswan in the south to the limestone quarries of Tura across the river. Yet, despite the vast distances and the thousands of people involved, the central directive remained uncorrupted, true north, within 3/60ths of a degree. This speaks to a bureaucratic efficiency that is as impressive as the stone masonry. The ability to coordinate such a complex operation without the aid of modern communication suggests a social hierarchy that was rigid, disciplined, and unified by a common belief in the divinity of the pharaoh and the necessity of his eternal journey. As we scrutinize the corners of the base, we find the corner sockets cut into the bedrock. These sockets are key to understanding the initial survey. They mark the extreme corners of the pyramid's foundation and were likely the primary reference points established during the stretching of the cord. The distances between these sockets are equal to within incredible tolerances, forming a near-perfect square. The diagonals are equal, proving the squareness of the corners. This geometric perfection at the very bottom layer, the layer that would be buried under millions of tons of stone, indicates that the ritual importance of the layout was paramount. Even if the outer casing eventually hid the foundation, the gods would know it was perfect. The hidden geometry was a message to the cosmos, not just the observer on the ground. The legacy of this alignment echoes through history. It challenged later civilizations to match its precision. It puzzled the Greeks and Romans, who marveled at the Egyptians' mastery of geometry. It continues to provoke modern researchers to question our assumptions about the linear progression of technology. We tend to assume that the past was primitive and the future is advanced. The Great Pyramid disrupts this narrative. It stands as a monolith of anomaly, a structure that was built with primitive tools but exhibits advanced characteristics. It forces us to broaden our definition of technology. If technology is the application of knowledge to solve problems, then the Egyptians possessed a spiritual technology or cognitive technology that allowed them to leverage the human mind and the collective body in ways we have forgotten. They didn't need satellites because they had a sky full of stars and the patience to watch them for centuries. They didn't need lasers because they had the sun and the shadow. They didn't need computers because they had a priesthood dedicated to the preservation of mathematical truth. In the silence of the desert night, if one stands at the base of the Great Pyramid today and looks up toward the pole, the stars have shifted. Thuban has moved away, and Polaris has taken its place. The alignment is no longer perfect relative to the current sky, but the stone mountain remains, a testament to a specific moment in the deep past, when humanity reached up and locked its greatest creation into the clockwork of the heavens. The deviation is not a failure. It is a timestamp. It tells us exactly when they stood there. It validates their effort. And it reminds us that while the stars may drift and empires may fall, the desire to find our place in the universe, to orient ourselves against the infinite, is the most enduring alignment of all. This obsession with cosmic orientation did not stop at the mere cardinal directions, for the alignment of the Great Pyramid is not a two-dimensional feat restricted to a compass on the ground. It is a three-dimensional triumph that integrates the flatness of the Earth with the curvature of the sky. Before a single block could be set to mimic the stars, the plateau itself had to be prepared with a degree of accuracy that rivals the optics of modern telescopes. The builders were not merely placing stones on sand, they were sculpting the bedrock of the planet to serve as an altar for their geometry. The 13-acre base of the Great Pyramid is level to within less than an inch across its entire diagonal. This is a staggering achievement in civil engineering that would be difficult to replicate today, even with laser leveling technology. Yet it was accomplished with copper chisels, stone pounders, and the elemental physics of water. The prevailing theory suggests that the architects cut a grid of trenches into the limestone bedrock, filled them with water, and marked the water line against the stone. By chiseling down to the water level, they created a reference plane of absolute flatness, dictated by gravity itself. This water leveling technique speaks to a mindset where nature was not something to be overcome, but a tool to be utilized. The water, the stars, and the sun were the instruments of the trade. Once the water was drained and the trenches filled with masonry, the site became a blank canvas upon which the cardinal axes could be drawn. This preparation phase alone represents a colossal investment of labor and time, undertaken before the construction of the monument even began, proving that the precision of the foundation was as spiritually significant as the height of the capstone. Once the foundation was laid, the challenge of maintaining that perfect north-facing orientation became a daily battle against the chaos of construction. As the pyramid rose, the horizon was obscured. The surveyors could no longer stand at the center of the base and look at the northern stars, because the rising bulk of the pyramid blocked the view. They had to transfer the alignment upwards, layer by layer, without losing the thread of accuracy. This required a system of internal checks and external reference points that have mostly been lost to history, though the evidence of their success remains in the stones. The deviation of the sides is measured in arc minutes, a unit of angular measurement so small it is usually reserved for astronomy, not masonry. To maintain such a line while stacking 2 million blocks of stone suggests a supervisory rigor that bordered on the fanatical. Every layer had to be verified, every corner stone rechecked against the stars, ensuring that the axis of the pyramid remained perfectly parallel to the axis of the Earth. This vertical discipline leads us to one of the most mysterious features of the Great Pyramid, which further cements the connection between the terrestrial structure and the celestial sphere. Piercing through the solid masonry of the superstructure are 4 narrow shafts, 2 originating from the king's chamber and 2 from the queen's chamber. For decades, Egyptologists dismissed these as ventilation shafts, a pedestrian explanation for a structure that was essentially a sealed tomb. The idea that a dead pharaoh needed fresh air seemed absurd,
Yet the name stuck until modern robotics allowed us to explore them. These shafts are not horizontal. They are inclined at precise angles, shooting upward through the core of the pyramid to the outer casing. When astronomers calculated the alignment of these shafts relative to the sky of the 4th dynasty, they discovered that they were not merely air ducts, but star cannons. The southern shaft of the king's chamber pointed directly to Al-Nitak, the lowest star in Orion's belt, associated with the god Osiris, the lord of the afterlife and the judge of the dead. The northern shaft pointed to Thuban, the pole star of that era, associated with cosmic stability and the pharaoh's eternal endurance. In the queen's chamber, the southern shaft targeted Sirius, the brightest star in the sky and the celestial manifestation of Isis, the mother goddess and wife of Osiris. The northern shaft of the queen's chamber pointed to Kochab, a star in the bowl of the Little Dipper, associated with the indestructibles, the circumpolar stars that never set, and thus possessed the secret of immortality. These alignments were not accidental windows. They were architectural psychopomps, machines designed to launch the soul of the deceased directly into the specific regions of the sky where he would take his place among the gods. The engineering required to build these shafts is mind-boggling. The builders had to construct inclined tunnels at a constant angle through horizontal courses of stone. This meant that every block surrounding the shaft had to be cut with a complex sloping channel. If the angle drifted by even a degree, the shaft would miss its celestial target. They were building a telescope out of limestone, fixed in place for eternity. The presence of these shafts proves that the alignment of the pyramid was not just about the cardinal directions on the ground. It was about anchoring the monument to a specific mythological geography in the sky. The pyramid was a terrestrial anchor for a celestial web, connecting the king to Osiris and the queen to Isis, locking the dynasty into the rotation of the heavens. This connection to Orion leads to one of the most provocative theories regarding the placement of the Giza pyramids, one that expands the scope of alignment from a single monument to the entire plateau. The layout of the three main pyramids, Khufu, Khafre, and Menkaure, has long puzzled observers. While the first two are roughly the same size and align along a distinct diagonal, the third pyramid, Menkaure, is significantly smaller and offset to the east of that diagonal. For centuries, this was viewed as a topographic necessity or a budgetary constraint of a declining dynasty. However, when one looks at the three stars of Orion's belt, Al-Nitak, Al-Nilam, and Mintaka, a striking correlation emerges. The two brightest stars are aligned perfectly, but the third, Mintaka, is smaller and offset slightly to the east. The theory posits that the Giza Plateau is a map of the Duat, the Egyptian underworld, projected onto the sands of the desert. The three pyramids are the terrestrial counterparts to the three stars of Orion's belt. The Nile River, flowing to the east of the pyramids, mirrors the Milky Way, which flows to the east of Orion. This concept, known as above, so below, suggests that the architects were not just building tombs, they were recreating the kingdom of heaven on earth to ensure the magical potency of the site. By miming the sky, they believed they could draw down the power of the stars. The offset of the third pyramid, often cited as an error or a failure of planning, turns out to be a precise replication of the celestial imperfection of Orion's belt. The builders were not failing to make a straight line. They were succeeding in making a star map. While the Orion correlation theory remains a subject of heated debate within academic circles, the mathematical properties encoded in the pyramid's dimensions are harder to dismiss as coincidence. The alignment to the north is a feat of orientation, but the shape of the pyramid itself is a feat of geodesy, the science of measuring the earth. If you take the perimeter of the Great Pyramid's base and divide it by twice its original height, the result is 3.14159, a number we know as P. This relationship is the same as that between the circumference of a circle and its radius. The pyramid is, geometrically speaking, a circle that has been squared. For a civilization that supposedly did not understand the value of pi, building a monument that embodies it to 4 decimal places is a statistical anomaly that demands explanation. Some argue that this is a chance result of using a rolling drum to measure distances, but the precision is too consistent. Furthermore, the dimensions of the pyramid appear to be a scale model of the Earth itself. If you take the height of the Great Pyramid and multiply it by 43,200, you get the polar radius of the Earth with remarkable accuracy. If you take the base perimeter and multiply it by the same number, 43,200, you get the equatorial circumference of the Earth. The number 43,200 is not arbitrary. It is a multiple of 72, the number of years it takes for the stars to drift 1 degree due to precession. This suggests that the architects possessed a knowledge of the Earth's dimensions and the cycle of the stars that was not rediscovered until the modern era. The implications of this are profound. It suggests that the Great Pyramid was intended to be a repository of knowledge, a library in stone. By encoding the dimensions of the planet and the mathematical constants of the universe into the structure, the builders were ensuring that this knowledge would survive any catastrophe. Papyrus burns, languages die, and oral traditions fade, but a mountain of stone aligned to the stars is a message that can be read by any civilization intelligent enough to measure it. The alignment to true north serves as the key to this library. It tells future explorers that this is not a random pile of rocks, but a calibrated instrument. It invites us to measure, to calculate, and to understand. The sheer scale of the logistical operation required to achieve this alignment without satellites is difficult to overstate. We must imagine the Giza Plateau not as a silent ruin, but as a bustling industrial complex filled with the noise of thousands of workers. Yet, amidst the dust and the shouting, there existed a core of silence and absolute focus. The surveyors and the priests, their tools were simple. The merket, a notched palm rib, the bay, a sighting tool, and the plumb bob. With these primitive instruments, they achieved a level of accuracy that we strain to match with GPS. The merket allowed them to track the movement of stars across the night sky, creating a local timekeeping system that governed the work. The process likely involved the Indian circle method or a variation thereof to determine the cardinal points. A gnomon, or vertical rod, was placed in the sand. As the sun rose and set, its shadow would lengthen and shorten. By marking the points where the shadow was the same length in the morning and the afternoon, and drawing a line between them, the builders could find true west and east. A line bisecting this would point to true north. While the concept is simple geometry, executing it over a span of 750 feet with millimetric precision requires a control of variables that is almost superhuman. The ground had to be perfectly flat, the rod perfectly vertical, the measurements exact. Any error in the initial layout would be magnified as the pyramid grew, resulting in a twisted, unstable structure. The fact that the Great Pyramid is not twisted, that its corners form near-perfect 90-degree angles, is a testament to an obsession with perfection that permeated every level of the workforce. This drive for alignment extended to the casing stones, the smooth, white Tura limestone blocks that once covered the pyramid. These stones were cut with such precision that the joints between them were thinner than a credit card, barely visible to the naked eye. They were polished to a reflective sheen, turning the pyramid into a beacon of light that could be seen from miles away. The alignment of these casing stones was critical. They were the skin of the machine. If they were not angled correctly, the geometric purity of the pyramid would be lost. The builders used optical precision on a scale of millions of tons. The surviving casing stones at the base of the Great Pyramid show a deviation from a straight line of only 1/100th of an inch over a length of 6 feet. This is the kind of tolerance we expect in the machining of engine parts, not in the construction of a Bronze Age tomb. We must also consider the role of the stretching of the cord ceremony, a ritual depicted in temple reliefs where the pharaoh and the goddess Seshat drive stakes into the ground to mark the corners of a new holy building. This was not merely symbolic. It was the moment of alignment. The text described the pharaoh looking at the sky, observing the stars, and turning his gaze toward the Great Bear. This confirms that the orientation was an active astronomical process led by the highest authority in the land. The alignment was a divine mandate. To build out of alignment was to introduce chaos, or Isfet, into the world. To build in alignment was to uphold Ma'at, the cosmic order. The accuracy of the pyramid was a moral imperative. The specific method used to align the Great Pyramid to the north so precisely, more precisely than the earlier pyramids and the later ones, may have relied on the simultaneous transit of 2 circumpolar stars. In the year 2467 BC, the stars Mizar in the Big Dipper and Kochab in the Little Dipper appeared to rotate around the celestial pole in such a way that a vertical line drawn between them would pass directly through the true pole. As the Earth precessed, this alignment slowly drifted. By analyzing the slight errors in the alignment of the pyramids of Khufu, Khafra, and Menkaure, researchers have been able to date them with extraordinary precision. The error matches the rate of stellar drift perfectly. This means the pyramids are not just aligned to the stars, they are chronometers. The slight deviation from true north is not a mistake. It is a recording of the date of construction, frozen in stone. This revelation transforms the pyramids from static monuments into dynamic instruments. They are capturing a moving sky. The builders understood that the stars were not fixed, that the heavens were a shifting clock face. By locking the pyramid into the alignment of their specific time, they were placing a pin in the timeline of the universe. They were saying, "We were here at this moment when the stars looked like this." It is a form of communication that transcends language. A written date can be mistranslated or debated, but a stellar alignment is a physical fact that can be reconstructed by any astronomer in the future. The complexity increases when we consider the internal geometry. The king's chamber is built according to the 3-4-5 Pythagorean triangle, centuries before Pythagoras was born. The granite coffer inside the chamber is sawed with a technology that has left drill marks, indicating a feed rate. The speed at which the drill cuts into the stone, that implies a hardness and pressure capacity comparable to modern diamond-tipped drills. This technological anomaly sits at the heart of the aligned structure. The precision of the alignment is matched by the precision of the machining. It paints a picture of a civilization that was operating at the absolute peak of its capability, mobilizing every resource, every mathematician, and every astronomer to achieve a singular goal. That goal was the transcendence of death through geometry. If the soul was to navigate the perilous journey of the afterlife, it needed a map and a vehicle. The pyramid was both. The alignment to the north ensured that the pharaoh would join the indestructibles, the stars that never died. The shafts pointing to Orion ensured he would become Osiris. The geometry of the structure ensured it would resonate with the harmonic proportions of the Earth. It was a machine made of limestone and granite, powered by the rotation of the planet, designed to transmute a mortal king into an immortal star. The skeptical view is that we are projecting modern anxieties and knowledge onto ancient builders, seeing patterns where there are only coincidences. Yet the statistical probability of so many coincidences stacking up on the same plateau is vanishingly small. The orientation to true north, the encoding of P and Phi, the geodetic dimensions, the shaft alignments to specific stars, and the Orion correlation all point to a unified design philosophy that was obsessed with the cosmos. To dismiss this is to underestimate the ancients. It is to assume that because they lacked satellites, they lacked sophistication. But the evidence suggests the opposite. Because they lacked satellites, they developed a reliance on observation and a discipline of measurement that we have lost. They did not have digital screens. They had the horizon. They did not have GPS. They had the entire night sky. The legacy of this alignment is not just in the stones that remain, but in the questions they force us to ask. How did they know the dimensions of the earth? How did they carve granite like butter? How did they organize a labor force of thousands to work with the precision of a watchmaker? The Great Pyramid stands as a challenge to our chronological arrogance, the belief that the past was primitive and the future is advanced. In the specific context of alignment and geodetic precision, the Fourth Dynasty of Egypt achieved a zenith that was not equaled for 4,000 years. As the sun sets over the Giza Plateau, the shadows lengthen and the geometry of the pyramids becomes stark against the twilight. The alignment to the cardinal points means that the faces of the pyramid catch the light in a specific sequence, marking the equinoxes and solstices with shadow plays that confirm the structure's role as a solar calendar. The flash of the equinox, where the concave sides of the Great Pyramid briefly split the face into two distinct triangles of light and shadow, is a phenomenon that only works because of the extreme precision of the orientation. It is a visual verification of the alignment, a signal sent once every 6 months that the machine is still working, still calibrated, still watching the sun. This interplay of light and shadow brings us back to the human experience of the builders. They were not abstract theorists. They were observers of the natural world. They noticed that the sun rose at different points on the horizon throughout the year. They noticed that the stars circled a fixed point. They synthesized these observations into a theology that equated order with divinity. To align the pyramid was to participate in the divine order. It was an act of worship performed with surveying tools. The sweat of the laborers, the calculations of the scribes, and the commands of the pharaoh were all focused on this single point of convergence. In the end, the alignment of the pyramids is a story about the human relationship with the infinite, faced with the vast rotating dome of the stars and the endless cycle of the sun. The Egyptians did not shrink away. They did not build small huts and hide from the cosmos. They built mountains. They built artificial horizons. They inscribed their knowledge into the earth so deeply that not even time could wash it away. The fact that we are still debating their methods, still measuring their angles, and still marveling at their precision is proof that their project succeeded. They wanted to be remembered, not just as a powerful empire, but as a civilization that understood the sky. And every time we look at the Great Pyramid and measure its alignment to the north, we are validating that understanding. We are looking through their eyes, standing in their shadows, and realizing that 4,500 years ago, humanity looked up and found its place in the stars with a precision that still defies explanation.